Hello everyone, welcome to this course on advanced algorithm. Let's start the course with the topic by name string matching. In this video, we are going to discuss about some of the basic terminologies that we are going to use in case of string matching, as well as at the end we are going to discuss about the brute force string matching algorithm, or we can call it as the naive string matching algorithm. So let's start this course with the first topic as string matching. Now, as we know, in case of string matching, the main objective is to find a substring in a main string. Let me write the objective of this string matching problem as the objective is to find the substring in the main string. So this is the objective of any string matching algorithm, to find a substring, or I can find n number of substring in the main string. And in case of string matching algorithm, this substring is termed as pattern. Please note that the substring is termed as a pattern, and it is generally denoted with the character capital P. And the main string, in case of any string matching algorithm, we call it as a text. We call it as a text, which is denoted with T. So I can reframe the objective of any string matching algorithm is to find a pattern or to find patterns in a text, wherein pattern is denoted with P and my text is denoted with T. And one more important thing is, for all the string matching algorithms that we are going to discuss, let text T size be n. Let n denotes the number of characters in the text T, and let's assume the pattern, which is denoted with P, size is denoted with m. So these are the other two variables that we keep using in case of any string matching algorithm. First were capital T and capital P, which denotes the text T, or it denotes the main string, and my pattern is denoted with capital P, which is nothing but the substring. And generally my text size would be n and my pattern size would be m. Here let me take it as n characters and m characters. And in most of the cases, n is greater than m. That's one more assumption that we are going to do. So this is about some of the terminologies that we keep using in any string matching algorithm. Those are pattern, which is denoted with P. Pattern is nothing but the substring, and the main string, which is nothing but my text, which is denoted with T. The size of text, that means the number of characters present in text T will be n, and the number of characters in my pattern P, let it be denoted with m characters. Now coming to the string matching algorithm, some of the string matching algorithms are, the first and foremost that we are going to discuss is the naive string matching algorithm. Is the naive string matching algorithm, or we can call it as a brute force string matching algorithm. Brute force string matching algorithm. The second one, these are some of the algorithms. Second string matching algorithm is Rabin-Karp string matching. Third one is finite automata based string matching. And KMP string matching, which stands for Kruth-Morris Pat string matching algorithm. So these are some, maybe I can list one more, say Horspool string matching algorithm. So these are some of the popular string matching algorithms that we come across in case of algorithms. So name string matching, Rabin-Cox string matching algorithm, finite automata based string matching algorithm, KMP string matching algorithm, and Horspool string matching algorithm. Now in today's video, we'll see what do you mean by the name string matching algorithm, as well as we'll discuss what is the time complexity and what are the best and the worst cases of the name string matching algorithm. Before directly going to the naive string matching algorithm, let me take some example to make you familiar how exactly the naive string matching algorithm works, and then it will be easy for us to write the algorithm and to analyze the time complexity. So let me take an example. Let me take the first example. Let me assume that my text is denoted with A, B, C, D, A, B, F, A, B, E, G something, and let my pattern be denoted with AB. Let me take my pattern as ABE. This quite yeah. So this is my text. Note that my text has 3, 6, 9, 11 character. The size of my text is 11 characters. So this is 11 characters. In a sense, my value of n is 11. What about my pattern? My pattern size here is 3 characters. That means m value is 3. Now generally what we do is we align the pattern with the text. First we compare the first character of the pattern with the first character of the text. So this matches. Now we compare the second character of the text with the second character of the pattern. This also matches. Next I compare the third character of my text with the third character of my pattern. So there is a mismatch here. Now whenever there is a mismatch in the characters of the text and the pattern, I need to shift the pattern to its right side. So what I need to do, now I shift my pattern here. This is A, B, E. Now I compare B with A. This does not match. In my previous iteration, I had done 3 comparison. For the third character, it was not matching. But whereas in case of second iteration, my first character itself is not matching. So B does not match with A. So I need to shift my pattern to its right side. So now my pattern is being shifted. So this is A, B, E. Now I compare the first character of my pattern with the character in the text. Now the aligned character in the text is C. So I compare with this two. So this does not match. Now I need to shift my pattern. So this is A, B, E. Now I compare this B with A. This does not match. I need to shift my pattern. So this is A, B, E. Now I compare A with A. In this iteration it matches. Now I compare B with B. This matches. Now I compare F with E. This does not match. So whenever there is a mismatch, I need to shift my pattern to its right side. So now A, B, E. Now I compare this B with this A. If you see, this does not match. So I'll shift my pattern A, B, E. Now I compare this F with A. F with A does not match. Now I'll shift my pattern. A, B, E. Now I'll compare this A with this A, this matches. Now I compare this B with this B, this matches. I'll compare this E with E, this matches. So if you see, this matches, the first character matches, the second character matches, and the third character matches. So this is how the naive string matching algorithm works. So first we need to align the pattern with the first few characters. That is, I need to align my pattern with the first m characters of the text. I need to compare the first character. If it matches, I go for the second character. If this matches, I go for the third character. If in this case the third character does not match, I'm shifting my pattern to 1 to its right side. Now I am comparing the second character of the text with the first character of the pattern. So here in the second iteration, the first comparison fails. The first comparison itself fails, so I am shifting my pattern to 1 to its right side. Now in the third iteration also, the first character comparison only fails. So note that in case of a naive string matching algorithm, the shift size is limited only to 1. I can shift my pattern by only 1 to its right side. So with this, what we can do? We can we'll come up with few more examples later. First we'll come up with the algorithm. Let me write the name of the algorithm as naive string matching or matcher. So first step would be, I'll try to get the length of my text. So earlier I have told, let's use a variable n which denotes the size of my text. So first step would be n is equal to t dot length. Let me assume that there is some function in any of the programming language which gives me the size of that particular string. So here I am taking it as length. So n is equal to t dot length. So second step would be m is equal to, what was m? M was nothing but the length of the pattern. So p dot length. So with this, what is the input to the algorithm? So there are two inputs. One input is the text and the second input is the pattern. What was the objective? Objective was to find whether the pattern is there in the text or not. Third step would be for s is equal to 0 to, this is nothing but the number of iterations. So in the previous example you saw that we got the answer somewhere in the 7th or the 8th iteration. I may go up to n minus m iteration. So this is for s is equal to 0 to n minus m. N minus m. Actually it is 0. It is nothing but n minus m plus 1 iteration. As I am taking it from 0, so it is from 0 to n minus m. So fourth one is what we used to do in each iteration. In each iteration we used to compare the pattern, a character in the pattern with a character in the text. So if p of 1 dot 1 to m, that was the size of the pattern was m. So 1 to m, if this is equal to, if this is equal to t of s plus 1, because my text, I have taken an example, this was my text, let me take this as a B, C, A, E, F, G. So the size of my text was 7 characters. 7 character in the sense here it was indexed from 1 to n. That was 1 to 7. So I need to compare my first character. If my pattern was EF, then I need to, this was, pattern size is just 2. I need to compare the first character of the text with the first character of the pattern. If p of 1 to m is equal to t of s plus 1, what was the last iteration? Last iteration was s plus m. So if this condition is true, then I will print pattern p occurs at shift s. So this was the naive string matching algorithm. Hope the algorithm is clear. Let me take some more example to make us understand what would be the best case scenario of string matching algorithm and what would be the worst case string matching algorithm. Before going to that, let me come to the time complexity. Let me come to the time complexity of the naive string matching algorithm. Here you saw that the basic operation is the comparison. I need to compare. So in worst case, in each iteration I may do m number of comparison. And the number of iteration is from 0 to n minus m. So this is n. This for loop will be executed n minus m plus 1 time, because as it is starting from 0, and in each iteration I may do only just one comparison. If a character of my text, if any of my character in the text does not match with the first character of my pattern, I will do only one comparison and I will do a shift. But in worst case, I may do m number of comparison. So the total number of comparison is n minus m plus 1 into m. So this is nothing but nm minus m square plus m. So this is the actual number of comparison that we do in case of the naive string matching algorithm. Asymptotically, the value of m, as I told that n value is very high when compared to m. So we don't compare. We don't take into consideration this m square and m. So I don't consider. We don't consider. So the efficiency is order of nm. Order of nm. So note that the efficiency of the string matching algorithm is order of nm. Now there will be a best case if my string is there in the beginning of the text itself. In the sense, if my pattern is there in the beginning of the text, that would be the best case. So we'll take one example to analyze what would be the best case and what would be the worst case. Now to analyze best case, let me take the pattern. First let me take the text. Let me take the text as a B, C, D, E, F, G, H. So which had 8 characters. If you see, the length of text is 8 character. And what would be, let me take my pattern. Let me take my pattern as ABC. Which is just 3 characters. So now if I want to perform a naive string matching algorithm, I align the first 3 characters of the pattern with, I align the m characters of the pattern with the first m characters of the text. This has been aligned. Now I do a comparison here, it matches. I do a comparison here, it matches. I do a comparison here, it matches. So this would be the best case. Best case means if the pattern is there in the beginning of the text. Beginning of the text. Now how many comparison I have done? The number of comparison I have done is 3, which is nothing but the size of the pattern. So in best case of naive string matching algorithm, number of comparison is m. We do m number of comparison. Now in this case I have done just 3 comparison. So this is about the best case. Now let me take one more example to understand what do you mean, what exactly is the worst case scenario of the naive string matching algorithm. So let me have my text as A, B, C, D, E, F, G, H. So here it is just the number of characters is 8, and let me take my pattern as, most of the people get confused. If I say the best case scenario of the naive string matching algorithm is if the pattern is there in the beginning of the text, then it would be the best case. So obviously the other case would be if the pattern is there at the end of the text, that would be the worst case scenario. But actually it is not so. Let me analyze why it is not so. So if I assume that I am trying to search a pattern, FGH. So which is there at the end of the text. Now how exactly naive string matching algorithm works? I compare the first character A with first character F. This does not match. Now I move my pattern to the next position, that is to 1 to its right side. Now I compare B with F, this does not match. Now I just shift it 1 to its right side. Now I compare C with F, this does not match. Now you just note, okay, in first iteration how many comparison I have done? I have done one comparison. In the second iteration I have done one comparison. In the third iteration also I have done one comparison. Now let me go for fourth iteration. Fourth iteration, this is F, G, H. So I compare D with F, this does not match. This is just one comparison. Now I just move to its right, F, G, H. I compare E with F, this does not match. Here I do only one comparison. Next I move to its right side, F, G, H. Now I compare F with F, it compares. F with G, it compares. H with H, it matches. So there's a match here, there's a match here, there's a match here. The number of comparison is 3. So total number of comparison that I have done is 3 plus 2, 5, 5 plus 3, 8. So note that here in this example I have done 8 comparison. I have done 8 comparison. That means when my pattern is there at the end of the text, I have done just 8 comparison. But this is not the worst case. Note that, please note that this is not the worst case scenario. Why? Because, let me take one more example of the same. How many characters are there here? 8 characters. Let me take those 8 characters as A. Let me take 8 is 3 plus 2, 8. So this is 8 characters. And let me take my pattern. How many characters I have taken? 3 characters here. I will take it as 3. A, B. This is 3 characters. Now just see. So in the first iteration, I compare A with A, this matches. I compare with A with A, this matches. I compare A with B, this does not match. So how many comparisons in case of first iteration? It is 3 comparisons. Now I move a little further. That means as there was a mismatch, I need to shift my pattern to 1. This is the limitation of naive string matching algorithm. In case of naive string matching algorithm, the pattern can be shifted only to 1 to its right side. Now in the second iteration, I do 3 comparisons. This does not match. Next, in the third iteration, I do 1, 2, 3. I have done 3 comparisons. There is a mismatch here. Now let me take the last one as a B. Next, I will shift it A, B. There is a match here, there is a match here, there is a mismatch here. But number of comparisons is 3. Next, A, B. So there is a match here, there is a match here, there is a mismatch here. 3 comparisons. Next, A, B. So there is a match here, there is a match here, there is a match here. Number of comparisons is 3. Please check the number of comparison that we have done. 3 plus 3, 6, 9, 12, 15, 18. 18 comparison. In my earlier case, the number of comparison was 8. Please note that the worst case scenario of a naive string matching algorithm is not when my pattern is there at the end of the string. It is not just only that condition. In this case, the condition is true, but it is not just only one condition. The other condition is in each iteration, I should do m number of comparison. So the worst case scenario of the naive string matching algorithm is in each iteration I should do m number of comparison until the last iteration. That would be the worst case scenario of the naive string matching algorithm. Hope this is clear. In the next video, we will see about the Rabin-Karp string matching algorithm, how efficient is Rabin-Karp string matching algorithm when compared to the naive string matching algorithm. Thank you.